Okay, question 2. If we're going to explain why UV light will not discharge a positive plate, we need to say, first of all, say that the photoelectric effect is discharging electrons. We then need to explain that the electrons are negative, and therefore that if we are going to shine the UV light onto something that's positively charged and emit negative electrons, we're not going to discharge it, it's just going to become more charged. So words along those lines is what's required here. This question is interesting because it's really asking two things in one, and you need to discuss this first, the threshold frequency, and then this idea of work function. So to show threshold frequency, what we need to do is we need to fix a metal, and I decided to be shown a negatively charged zinc plate. Where they're going to shine the different lights on them and explain that light number 1 would not discharge the plate and 2 and 3 would, and that will show that the frequency of light source 1 and 2 is sufficient to discharge the metal. Now we're implying, there's an implied thing here, that we understand that the E equals HF, which I've said on the other page. I'm not sure if it's necessary to go into the idea about stopping potential. I don't really think it is, but you could show precisely what the threshold frequency is if you could basically change apply stopping potential to stop any electrons being emitted as well. As for the work function, we're going to demonstrate that by fixing a light source and shining it on different metals. So I've said we want to shine light source 2, because that will show some change across the 3 metals. Okay, so shining this light on all 3 metals, as long as they're charged negatively, would therefore demonstrate that only zinc is discharged, but both iron and copper are not. And this you could again verify this and show what the work function is or calculate the work function with the use of a stopping potential. So the way the stopping potential works, if you want to go into that, we know E equals HF. So the kinetic energy of the electron is given by HF minus the work function. So the kinetic energy is HF minus the work function, and if we apply a very small voltage to the surface of the plate, a positive voltage, then we can basically stop the electron from being able to leave. And what we're saying here is that the kinetic energy that the electrons would have is equal to the work done by the electrons overcoming the voltage that's attracting them. So we can, by knowing this, and knowing this, we can work out the work function. That's really what I'm saying in that bit. Although I don't think you need to go into stopping potential. You just need to say that first 3 marks is that you're changing keeping the metal the same and changing the lights. The second mark is say keeping the light the same and changing the metal. Right. Then it asks us to calculate the kinetic energy of the electrons emitted from a zinc plate when illuminated with the ultraviolet light. It gives us the work function in electron volts, but it wants the answer in joules. So EK equals HF minus the work function. We know Planck's constant from the formula sheet. We know the frequency, 1.2 times 10 to the 15, and we just got to turn this work function into joules, which is called 4.3 times by 1.6 times 10 to the minus 19. That's the conversion for electron volts to joules. That comes out to 1 times 10 to the minus 19 joules. We want to explain why this answer is maximum. Well, some of the electrons are ejected from atoms within the metal's surface. They're sort of below, not really below the surface, but they're deeper within the surface than the ones that are right on the surface, and so they have less kinetic energy. That's all there is to that.